Rocky, shh.
Hi everyone, so today we will be multiplying, dividing fractions. So our learning intention for today is to know about algebra, to be able to simplify algebraic fractions, remembering that there would be different operations. We previously learned how to add and subtract them. So today we will be focusing on the two operations, which is multiplying and dividing. Okay, and then hopefully at the end of this lesson, we will be able to explain to each other how the rules in multiplying, dividing fractions are developed. Okay, so I've divided our success criteria there depending on which step in learning you're targeting, right? So emerging would be to multiply and divide fractions. Approaching would be multiplying, dividing simple algebraic fractions with numerical denominators, so no algebra on the bottom. Meeting is what we will be learning in year 10, because the approaching bit is what we learned in year 9, but meeting here is what we want to learn here this year, 10.5.2. And if we want to extend a bit further, then this one here is the work that the 5.3 course would be asking you to do. Okay, so there are two tasks on Maths Online that I've assigned you to do. One is about multiplying and the other one is about dividing. Okay, so just like what we did with adding and subtracting, we first looked at how does it work with just numbers, and maybe we can use that knowledge so that we'll be able to apply it to algebraic expressions, or with this time algebraic fractions. Okay, so when we're multiplying, we say 1/2 times 1/2 is getting the half of a half. So if we start off with getting the half, right? So, and then getting half of that. So if we draw another half there, and the one we want to get is actually this bit here, which I want to shade properly, would be 1/4. And therefore, that means this one here is 1/4. Okay, and we can do that with the other one. This time here, we've got 1/3 of a half. So again, we shade in what's 1/2. That's 1/2. I shaded it a little bit properly than the other one. So that's a half. We want to get 1/3 of that. So we divide it horizontally. Sorry, hang on. Into thirds. The best way we can divide them into equal parts. It doesn't look like it's equal parts, but we can live with that. And we just want 1/3 of what we've already marked as a half. And therefore, that bit there would be this one here, right? And therefore, what do you think is that fraction? That fraction represents 1/6, because it's 1 part out of 6 equal parts. Okay. Now, the next one, we've got there 1/4 of a third. So we color in 1/3, and we just want 1/4 of that. Okay, so 1/4 of that, let's halve it first, and then half it again, so that we've got quarters there. So we just want 1/4 of that would be this, and essentially that's 1 out of how many parts altogether? That's 1 out of 12. Now, if we do that again, we shade 1/5. Where is 1/5? That's 1/5. We want to get half of that, and therefore we have this bit here, and that is 1 out of 10. Okay, and then we have 2/3 of 1/2. So we shade the 1/2 here. We want to get 2/3 of that. Right, so we want to essentially color in 2 of that 1/3, or 2 of 3 parts of the 1/2, sorry. And therefore, that's what? That's 1/2 out of 6 parts, and therefore that's 2/6, Or really, if we simplify that, we get 1/3. We can see that from when we say, well, this is one part, that's another part, yeah, and this is also another part which has of equal size as these other two parts here, right? And therefore that's really just 1/3. So I don't know if you were able to get it from or find that pattern. What pattern can you find if we would be drawing those fractions? Really, what we can see here is that when we multiply fractions, we multiply the top, we get 1, 2 times 2, you get 4. 1 times 1 on the top, you get 1, 3 times 2, you get 6. The same thing with those that aren't unit fractions, just like 2/3 times 1/2, you get 2 times 1, you get 2. 3 times 2, you get 6. And you simplify that to get 1/3. Okay, so you would have guessed that with this one here, let's start with, we want 3/4 of 2/3. So we want to shade in 2/3 first, and therefore we want 3/4. So we divide by 4 horizontally, and we just want 3/4 of that, and we shade this bit. Okay. And how many parts is that I've shaded in? You've got 1, 2, 3, 4, 5, 6. 6 out of 12, which is really 1/2, right? And similarly to the previous video that we saw, when we're multiplying, because we know that we simply multiply the top and multiply the bottom, then instead of us looking for, multiplying them and then ending up with a large number, right, and then simplifying it later on, what we could do is we can cancel out the 2 and the 2, right? And therefore that becomes 1, that becomes 1. Essentially, we're multiplying 1 times 1 on top and then 3 times 1 on the bottom. The same thing with the next one. We could say these two cancel out, right? They become 3 becomes 1, 3 becomes 1 as well on the bottom. And we've got 2 and 4, 2 becomes 1, 4 becomes 2. And therefore you've got 1/2. Okay, so I want you to think about another example. So come up with your own example, and then maybe ask your partner to answer that for you. Okay, so let's have a look at what we learned in Year 9 for this one here. If you notice, you've got here the fractions that you multiplied and divided in Year 9. Let's have a look at what we will be doing this year. Well, it looks like we've got a few other ones that would look like a bit more complex, only because it would involve some binomials there, right? The same thing with the ones that we want to do with division. Okay, what the 5.3 course would look like would be something like this one, which is question 7 of exercise 7.4, which would require you to first factorize these quadratic trinomials before you can cancel out some common binomials. Okay, so having that big picture there of how algebraic fractions works within Year 9, Year 10, 5.2, and then 5.3 would probably give you a better idea of what you want to achieve for this lesson. The first one there, we've got x over 2 times by 6 over y. We said that when we multiply, well, we could look for some common factors, right? And therefore we've got 6 and 2, that becomes 3, and that becomes 1, and therefore we've got 3x over y. How about the next one there? We've got 2 and 2 cancel out. The y and the y cancel out. The 1 on top becomes z over what? 2 times x times 3, which is 3x, right? So you just multiply the top, multiply the bottom, but before you do that, you want to cancel out the common factors so you don't end up with a crazy answer and then simplify later on, okay? The same thing with division, right? So we've got 1 over x, we divide. How do we divide fractions? We flip the second fraction, and then proceed with multiplication. And then before proceeding to multiplication, get rid of your common factors first. In this case, it would be x, and therefore the top becomes 1 over 4. And for the next one, you've got 3xy over 2 multiplied by 9y over 4x, right? And then you've got, you can cancel out the x and the x here, right? We can't cancel the 3 and the 9. We can't cancel the y and the y, and therefore we've got 27 y squared over 8. Okay, now let's try those ones that we want to show or demonstrate in Year 10. Let's multiply these two. Let's cancel out some common factors so we don't end up with a crazy answer. We've got 3 and 6, that becomes 2, and that becomes 1, right? We can cancel out the y's, and therefore on top we got 5 times 2 times z, which gives us 10z over 1 times x times 7, you get 7x. All right, now the ones with the binomials here, remember that these binomials here, you can't cancel them one at a time, they go together, they're just one group together. Okay, and therefore how do you cancel them? You need to cancel x plus 1 as a whole thing and x plus 1 as a whole thing there. And remember, you can only cancel common factors if 1 is on top, 1 is on the bottom. Okay, you need to cancel the x and x there, right? You can't cancel the 2 and the 2 there because the 2 is part of this binomial here, right? Therefore, you're done with canceling. What do you have on top? You've got 2 over 2x minus 3. And that's your final answer. You can't cancel the 2 and the 2 here because, again, this 2 here is part of this binomial here. Okay, right? How about with division? Very similar. You've got 3xy over 2 times it by the reciprocal or the multiplicative inverse, 9y over 4x. You cancel out the x's, right? You can't cancel the 3 and the 9 and 2 and the 4, and therefore you've got what? 27y squared over 8. Did you notice that that one in Year 10 actually is exactly the same as what we've done a while ago? Yeah, so let's have a look at the one that's new. You've got 4 over x plus 1, 3x plus 5. Let's make that longer. We times that by the reciprocal, which is x plus 1, x minus 7. Okay, usually even if you don't have them in brackets, it's easier if you actually add on the brackets. Okay, so you know that they are together. They are one factor. Okay, and therefore you need to cancel these, right? Are there anything else that you can cancel here? There's none, and therefore the one on top would be 4. On the bottom, you get 3x plus 5, x minus 7. Okay, now once you're happy with that, you might want to try and log on to your box of books, accessing your Jacaranda Learn On, and answer the questions that I've assigned you. It's 7.4, so I've specifically assigned only a few questions there for 7.4, right, which would be about the 5.2 work that we're doing here. Okay, now if you're looking for, you can pause or stop the video now if you don't want to be doing the exceeding part, which is what would 5.3 look like, right? So how do we simplify this? We want to firstly factorize x squared minus 2x minus 3. How do we factorize that? We're looking for factors of -3 that when we add, we get -2. So that would be x minus 3, x plus 1, right? What are the factors of x to the power of 4 minus 1? You could probably say it's x squared plus 1, x squared minus 1, right? Times it by factorizing x squared plus 4x minus 5 gives you, what are the factors of -5 that when you add, you get 4. You get x plus 5, x minus 1 over factors of x squared minus 5x plus 6. Factors of 6 that when you add, you get -5. You get x minus 2, x minus 3. And then because we're dividing, we can actually just swap these two around. Let's start with this one here. What are the factors of x to the power of 4 minus 3x squared minus 4? Factors of -4 that when we add, we get -3. That's x squared, minus 4, x squared plus 1, x squared plus 1. And on the bottom, which are the factors of the one here on top, you get x plus 5, x plus 2. Okay. Now, what can we cancel out here? Remember that when you cancel them, you need to have one on top and one on the bottom. So let's maybe do it systematically, just like how mathematicians would do it. We look at the first one. What can we cancel here? We can cancel the x minus 3 and x minus 3. Is there any x plus 1 here? X plus 1, that looks like it's x plus 1, but really it's not, because it's x squared plus 1. So we leave that. Is there any x plus 5 on the bottom? There's one here. Yeah. Is there any x minus 1 that we have here? Well, none yet, but we can maybe have a look at that again later, right? Let's have x squared minus 4. Well, we know x squared minus 4 would be what? X minus 2, x plus 2, right? That's your difference of two squares, and therefore you've got these factors cancelled out. You've got x squared plus 1, x squared plus 1, perfect, right? So that we've got, oh, look at that. You've got x plus 1 and then x minus 1, which are really the factors of x squared minus 1. And therefore, they cancel perfectly to say that that is actually equal to 1. How amazing is that? Yeah. So again, those ones are when it would require you to factorize them first and then look for those binomials that you can cancel, one on top and one on the bottom. Okay. For your extension bit, it's any of the questions from 7 to 10 of that exercise. Okay. And don't forget to complete your exit ticket too. You stay awesome. See you next lesson. Bye.
Come on, Rocky, let's go.